Fun problem today, we're going to look at what's the difference between this adding everybody up and then squaring, subtracting by squaring everybody and then adding them up. We'll do this for n. Here we're interested in n equals 100, but we'll start with n. The first term here we can just write out before we square it as the sum of all these numbers. And if we write it out again, we're actually going to add these together. And the reason we're going to add this together, this will give us 2 times the sum, is every term, when we add them together in this clever way, actually turns out to be n plus 1. And how many terms do we have? We have n terms. And so what do we get is we get n times n plus 1. And after we divide by 2, we're actually going to get what's in blue there. We'll end up squaring this formula, but the formula for the sum of numbers from I equals 1 to n is n times n plus 1 over 2. And then for us, we'll end up squaring it, but that's what goes inside the parentheses there. We can try the same thing on the other term. So here we have the sum of squares, and we can try, let's write it out again, flip it around, but the issue here is we don't fall into a nice little pattern. You can stare at that for a bit, but there's nothing, at least the same trick's not going to work, and so we're going to have to do something new. And what we're actually going to do here is look at our old formula. We know the sum of just I gave us something, if we distribute out our terms, that had an n squared in it. And so we're just going to guess that maybe the formula we want has an n cubed in it with some other terms in there. And if it was to be n cubed, well, we have 4 unknowns, so let's build 4 equations. And so if we look at n equals 0 through 3, we get these 4 equations. N equals 0 is nice because we get rid of a bunch of the terms. And the sum of 0 things is just 0. And so we get that d equals 0, and we can really just worry about 3 unknowns and 3 equations. And so our 3 equations here come from just our summation. So our left-hand side is just the sum of those terms squared, or the terms squared added together. And then we can just build our system of 3 equations. If we have 3 equations with 3 unknowns, we can actually just solve directly for what these values are. Here we're solving for a, b, and c. And I'm going to solve this by actually throwing the system into an augmented matrix, and then we're going to do row operations on the matrix, and then we'll back substitute to solve for the other 2 variables here. So here's our augmented matrix, and first thing I'll do is I'll take that first row, multiply by -8, add it to the second, multiply by -27, add it to the third, and then similar operations. What we end up with is this new system of 3 equations, which is easier to work with, and this is called back substitution. We get c equals 1 over 6, and we can go ahead and plug that into the first 2, and then now we're able to solve for b, and we'll get that b equals 1/2, and once we know c and b, we can get a. This is what's going to go into our green box. Now again, we don't know if this formula is correct, but if it comes of if the formula has a n cubed plus b n squared plus c n, then this is the formula that we expect to work, but now we need to prove that this formula is going to work. First thing we're going to do is we're going to factor and simplify this, pull out a 1/6, pull out the n, factor the n squared term, and this may be a formula that you recognize. We're going to prove that it actually works. This is going to be the formula that we use here. Our goal is to turn this into an equal sign, and we're going to do this with induction. First, for n equals 1, everything looks good. 1 equals 1. And now for the inductive step, we're going to assume this works for n equals k, and then everywhere we see k, we'll replace it with k plus 1, and that will be what we're trying to show. We're going to use this assumption to show what's on the right-hand side. And what I want to do here is take a pause and let you give it a try. Go ahead, pause the video here, and let us know in the comments how you did. All right, we'll start with the sum of the k plus 1 terms. That's the sum of the k terms plus the last guy. And now we know we need to use the assumption. So we use it there, factor out a k plus 1, and now we have a lot of algebra. We got to combine these fractions, get them all over 6, and then we're going to end up factoring the numerator, and everything's going to work out. And so our second term becomes this 1 over 6 formula, and from here we're just going to set n equal to 100 and get the answer directly. And that's all there is to it for finding the difference between the square of the sum and the sum of the squares. Hope you've enjoyed. Don't forget to like and subscribe, and I'll see you next time.